going to look at transformations of functions. There are 7 graphs of functions in this first part on your first 3 pages of your packet that you need to make sure you know. You need to study them, know the properties about them, and make sure that you could create them and recognize them. The first 2, I don't think you have to worry so much about memorizing because you're going to know these already. The first one is a horizontal line, which is always y equals some constant. So this one looks like y equals 2. Right, and it tells you some things about that. You could figure them out from the graph. All right, domain, it goes from negative infinity because it goes forever this way to positive infinity. And it could be any horizontal line and be that. Your range is always just going to be this one value, right? That's the only y value that's allowed. So the range is 2 on this particular one. Your function is constant, and it is constant from negative infinity to positive infinity. And the function is even. It is symmetric around the y-axis. So those are some properties that you might remember, or you could figure them out from your picture. The next one is also one that you would be able to do. Well, this is a special line. This is called the identity function, and it is the line y equals x. And so it goes through the origin, but it is a line. For your domain, it's going to go forever to the left and forever to the right, so negative infinity to positive infinity. Your range, as it goes to the left, it goes down. As it goes to the right, it goes up, so also unlimited. It is always increasing as you go from left to right. This one is symmetric around the origin. If you rotate it 180 degrees, it will look the same. This next one is the absolute value graph. Y equals absolute value of x. It will always look like a V. It can be moved around, but it's going to look like a V. Your domain, it's going to go from negative infinity because it goes forever toward the left, and positive infinity goes forever to the right. The range of this function is from 0 is your lowest point, and it goes forever up. The function is decreasing. This piece right here is decreasing. So from negative infinity up to 0. Remember, you're given the x values. That's decreasing. Increasing starts at 0, and it will go forever to the right, so to infinity. This is an even function. It is symmetric around the y-axis. I want to take the time to go through creating the absolute value graph. So if you have to do this, that you can pick the points. So it's not a line. That means you need more than 3 points, and you need a mixture. You need some positive and some negative. So I would go with 0, 1, 2, -1, and -2 to make my chart. When you plug in absolute of 0, is going to be 0. Absolute of 1 is equal to 1. Absolute of 2 is equal to 2. I won't write that one. Absolute of -1 remember, when you take the absolute, it's distance. So this is equal to +1. And the absolute of -2 would be +2. It's 2 units. So we'll graph this. So 0, 0, and we remember it's supposed to look like a V. 1, 1. 2, 2. -1, 1, and -2, 2. and it would keep going. So that is how to create the absolute value graph. Our next function is f of x, or y equals x squared. This is the standard quadratic equation, and it gives us a parabola. Your domain, it goes forever to the left, and it goes forever to the right. Okay, so negative infinity to positive infinity. Your range, lowest to highest, your lowest is 0, and it goes forever up. The function is decreasing from negative infinity to 0, and then it's increasing from 0 to infinity. The function is even. It is symmetric around the y-axis. We will create the standard graph y equals x squared. So we know it's a parabola. We're remembering that part from the standard graph. If we're going to create it, we need more than 3 points, and we need some positives and negatives. So I'm going to do 0, 1, 2, and then I'll do negatives to see how they react. Y equals 0 squared is going to be 0. Y equals 1 squared. 1 squared is going to be 1. Y equals 2 squared is going to be 4. To be careful when you plug in the negatives, it's going to go to the power. So this will give you back a positive 1, and negative 2 squared will give you back a positive 4. So we will graph these. So 0, 0, 1, 1, 2, 4. See, it's not looking like the V. Negative 1, 1, and negative 2, 4. It is a symmetric graph, so what it looks like on the right-hand side, it's going to look like on the left-hand side. This one is a curved graph. Next, we have the square root function. Y equals the square root of x. So remember how it looks. Your domain is going to start at 0, 0 to infinity. Your range is going to be from 0, that's your lowest, on your y-axis, to infinity. As it goes out, it will go up. The function is increasing from 0 as it goes all the way out. And this one is neither even nor odd. Next, we'll look at the creation of the function y equals square root of x. And so we can make a table for it. Now, you are restricted on the x's that you can pick because you want real numbers. You don't want complex numbers, so you're not going to be allowed to choose negatives under here. 0 is okay. 0 and higher is okay. So I'm going to choose 0. Square root of 0 is 0. Right? You can choose 1. Square root of 1. You really want perfect squares so that you don't have to graph decimals. So square root of 1 is 1. The next perfect square is a 4. So square root of 4 is 2. After that, 2 squared, 3 squared would be 9. So square root of 9 would be 3. So that should be enough to do our graph. So 0, 0, and we remember how it's supposed to look. So 1, 1, 4, 2, and 9, 3. So it climbs, but not very fast. And that is your square root graph. Next is our y equals x cubed function, which is the standard cubic function, and it is a curve that goes through the 0, 0 and then turns back. And you'll see when we plot some points, this little piece in here, if you just get 3 points, it looks like a line. So we're going to need more. For the domain on this function, as it keeps going down, it will go to the left. As it keeps going up, it will go to the right. So it is negative infinity to positive infinity. The range, it goes forever down, it goes forever up. So negative infinity to positive infinity. It is always increasing as you go from left to right. So negative infinity to positive infinity. And this is an odd function. If you rotate the graph around 180 degrees, it will give you back the same picture. It is symmetric around the origin. Let's look at creating the graph y equals x cubed. So we know we need more than 3 points. We know we need some positives and negatives. All right, so I picked our standard one. So if we pick 0, 0 cubed is going to be 0. If we pick 1, it's going to be 1. And 2 will give us 8. So this one is climbing then really fast. All right, when we pick negative 1, the negative goes to the power, but it's odd, so it's still going to give you negative. And same is true with the negative 2. The negative will go to the power, but it's odd, so it will give you negative. So we have 0, 0. We have 1, 1. And I'm going to jump down here and put negative 1, negative 1. See, if you just put those 3, you would think it's a line. We'll go back up, though, and we'll put 2, 8. And you'll see, oh, no, whoops, curves up that way. And negative 2, negative 8. It does help you to draw it, though, to remember what it looks like there in the middle. It looks like a line on those 3 points. And then it switches directions and climbs really fast. So that is y equals x cubed. There is one more function that you need to know, and this is the cube root function. It looks like the cube function, but it is sideways. So this is what it looks like. Your domain is from negative infinity to positive infinity, forever to the left, forever to the right. The range is also negative infinity to positive infinity, even though the movement is gradual. As it goes more to the left, it goes down, and as it goes more to the right, it goes up. So that gives your vertical movement. It is negative infinity to positive infinity. It is always increasing as you go from the left to the right. And this is an odd function. If you rotate 180 degrees, you would get back the same picture. Let's look at creating the cube root graph. So kind of like the square root graph, we have to think a little bit more about our points. And so what we want to pick for the x is perfect cubes. So 0 is good. Cube root of 0 is going to be 0. 1 is good. Cube root of 1 equals 1. Your next perfect cube. will be 2 cubed is 8. So your next perfect cube to choose would be 8 for x. The cube root of 8 is 2. Now, you can choose negatives for a cube root. So let's choose -1 and -8. So cube root of -1 is -1, and cube root of -8 is -2. Now let's put those on our graph and see if we have the right looking picture. So we have 0, 0. We have 1, 1. We have 8, 2. And this is looking right. So it goes out, right? And then we have -1, -1. And here is your little thing that looks like a line. And we have -8, -2. So to help us draw it. And now we're going to do some transformations to our standard graphs that we memorized. And the first one is a shifting translation. The first kind we look at is a vertical translation or a vertical shift. And this is when we have a positive real number. C is a positive real number, and it is added to the function. It's outside the absolute if we're doing absolute or whatever the function is. And if it's positive, if it's added, it's going to shift it up, or if it's minus, it's going to shift it down. And this is why it's important to remember how to draw your standard one, because you can draw your standard one and then this is going to say move it up 2. So let's remember our table for the absolute value graph. So we did 0, 1, 2, and then we did negatives. Right? Absolute of 0 is 0, absolute of 1 is 1, absolute of 2 is 2, absolute of -1 is 1, absolute of -2 is 2. And we'll put those on, and we remember it looks like a V. So this is our standard graph. Now, we can do this translation. So we're adding 2 and it's not in with the X. So it is a Y movement if it's outside that. And so it is going to move it up 2 spaces. Right? So there's 2 different ways you can go with this, or 2 that I can think of. And if it's an easy graph that you have here and you only have one thing to do, it's easy enough to just move the points. So this point is going up 2. That's why you want to be able to see your points on there. This one is going up 2. This one is going up 2. This one's going up 2. This one is going up 2. And that graph will look the same. It is just moved up 2 spaces. The other thing we could have done, if it's a more complicated graph with a couple of things to do, you can actually do the work on your table. So this is a Y movement. It's outside the X. I could have added 2 to all the Y's. So I would have a new table. My X would stay the same. And in the Y column, I would add 2. So 0 plus 2 is 2. 1 plus 2 is 3. 2 plus 2 is 4. 1 plus 2 is 3. And 2 plus 2 is 4. And this is going to be my new graph. and we can just verify 0, 2, 1, 3, 2, 4, negative 1, 3, and negative 2, 4. So that is an alternate way. Rather than just moving points from the graph, you can do it from the chart. So that's another reason to be able to make your chart quickly. So you want to remember what values to use. I'm just going to show this to you quickly on the graphing calculator. It's not necessary on a graphing calculator. It's easy enough to do by hand. But if you have one, you can always check it out. So I'm going to put both pictures on the same grid. So I'm going to enter y equals. And first I'm just going to do absolute value of x. And remember that absolute value, we're going to go under the math menu. And we have to go across, choose number, and the first one, we'll put our variable inside, and you have to close that parentheses. Right, that will be our first graph. And on the same grid, we're going to do absolute, so math menu, go across under number, the first one, absolute, x, close your parentheses, and then we're going to add 2. It's going to draw both of those, and it will draw the one we have second last. So there's our first one, and there's the second one, and you can see it's shifted up. You can look at your table, and it will give us 2 tables. And I'm going to just move this so we can look at the tables. All right, these are our x values, and this is with the first table. And if I wanted smaller values, I could go this way. All right, so this is our first one, and this x goes with the second column, the y2s. For my next problem, g of x equals absolute value of x minus 1. This is also going to be a vertical translation. It is outside the absolute. So it is going to be a y movement, a vertical movement. It's going to move the absolute value graph down 1 unit. So I went ahead and put the standard absolute value graph. It's going down 1 unit. You could move it from the graph. Every point is going down 1. And your new one is also going to look like a V. Whoops, that should have been right through that point. Or you could have done it with the table. And it is a Y movement, so you're going to work on the Y column and subtract 1. Keep your X the same, 0, 1, 2, negative 1, negative 2. So 0 minus 1 will be negative 1, 1 minus 1, 0. 2 minus 1, 1, 1 minus 1, 0, and 2 minus 1 is 1. And we can verify those. So 0, negative 1, 1, 0, 2, 1, negative 1, 0. That was right on here. Negative 2, 1. So you can do it just by moving the points when it's simple, or you can do it to the table of the graph. We'll look at just one more, and this one your function, your standard function is already drawn on there for you. So this is a translation of a parabola or an x squared graph. So x squared, and then you have plus 2. It is not inside with the x. So it's going to be a vertical movement. It's going to move your standard parabola up 2 spaces. So this will go up 2. This one will go up 2. This one will go up 2. This one will go up 2. And this one will go up 2. It's going to look like the same kind of picture. It has just moved up 2. Let's have a quick look on the graphing calculator. So I've done y equals. First we will do x squared. And next we will do x squared plus 2. If you have the TI 84 plus, you have to use your arrow to get off the exponent position before. All right, let's graph. So there's your standard one we had. There it's moved up 2. If we want to see the table, second table is above graph. All right, and this is our standard one. This is the one that is shifted up 2. So you can see each one of these you have added 2 onto the y's.